Hi, my name is Ryan Costa, and this is my gas laws chemistry calculator program in Java. So, using the Java programming language, I was able to make a chemistry calculator that is able to calculate four empirical gas laws, the ideal gas law, and a simple temperature conversion. And so, as you can see here, it's printing out through the J option pane message dialog. And by doing this, and by also using the \n, you're able to make several lines on only one window of text. So here is asking the first choice of asking what gas laws or operation you'd like to calculate, and depending on what the person puts, for example, if they enter A, then it will be the empirical gas laws, and the option pane will then print a list of the empirical gas laws, including Boyle's law, Charles' law, Gay-Lussac's law, and combined gas law, and so on. And it also includes options for B, C, and also else. See if the user enters an invalid answer, then the user is asked to input a valid answer again, which is right here. The option pane prints a message dialog saying that the invalid answer was inputted, and the user is asked again to input a value. And I also used a while loop here to get this done. So each time that a valid answer is inputted, then the loop becomes true and it exits the loop. But if the user puts an invalid answer, then it asks the user again using this false here. So going in further through the code, if the user enters A and then enters 1 for the first empirical gas law, then it's Boyle's law, and here I stated string variables, and also had a option pane print of the message dialog for the formula. And then the user was asked to input the initial pressure of the gas, which I made the variable Boyle's P1. And I also used a while loop to check if the value that they inputted was a number or not, by just checking if it can be parsed into a double. And I did that using try and catch. And the try part tries to parse it into a double, and if it's able to, it leaves this while loop, so it no longer tries anymore since it knows it's a number. But the catch part, if it catches the error, then the program realizes that an invalid answer was inputted, so it asks the user again, and the while statement is repeated using this true here. And I did this for actually every single time that the user is asked to input a value, because if the user inputs something that's not a number, then the program would be messed up. So therefore, I had to include that just to make sure that the program will run smoothly. And after the user inputs all the values, including one unknown, which I made it being 0, then my code tests for which variable is equal to 0. And depending on which one it is, it performs a certain operation. For example, if P1 in the Boyle's law calculation was put to 0, which means that it was an unknown for the user, then the double Boyle's P1 final is equal to the P2 times V2 divided by V1. And using this value that is calculated by the program, the user sees, using the previously entered values, the initial pressure is, and then blank, which the number is inputted into there, and then I put the unit millimeters mercury. So this was a very long code to perform all these tasks, and as you can see, all the way up until the very, I would say, middle of the program, which is around here, was just for the empirical gas law, since there was 4. And then I did 2 additional calculations after that, which was the ideal gas law, which used the same concepts as the empirical gas laws, meaning that I used while statements and try and catches to get the program to go past any errors and ask the user again for certain values. And most of the time I use doubles, as it allows for decimals instead of integers, which are just the integer value, so there's no decimals, as it allows for a more exact answer, especially in something as science. Exact answers are usually more desired than rounded answers, as it can make the answer more incorrect. And here at the bottom was my last calculation, which was temperature conversion, which is just going from Celsius into Kelvin. and the user is asked to input the temperature in degrees Celsius, as usually that's the temperature that's given. And using the same concept as before, I did a while and a try statement to check if the user actually inputted a number or a double. And if the user did, then it exits the loop and is able to actually parse the entered value into an actual double. And then that double is just added by 273, which gives you the approximate Kelvin value. And basically that was it. And here I'm going to run the code. So the user is just shown these different lines. Welcome to Ryan's Chemistry Calculator. This gas laws program provides a useful calculator for several gas laws integral to chemistry. And then it shows a list of the 3 different beginner options, which are empirical gas laws, ideal gas law, and interior potential conversion. And the user doesn't have to memorize that. It's asked again in the following question. Please indicate which gas law or operation you'd like to calculate. So for the sake of representation, let's do A for empirical gas laws. And then the user provided a list again of the 4 different gas laws included in the program. And just for this example, let's try to use 2, which is Charles' law. And here shows the formula. And here it's asking the user to please enter the initial volume of the gas in liters, which would be V1 in the formula. And if the user does not know that variable, for example, in most calculations there's one unknown variable, then the user response was 0, as it would be physically impossible for a variable to actually be equal to 0 in terms of measurements. So 0 was a safe value to use for unknowns. So let's say that the V1 is unknown, so put 0. And let's say that the initial temperature of the gas in Kelvin was 78. And the user must remember that all temperature has to be in Kelvin, as for all gas laws, Kelvin is the temperature unit used. And for final volume, let's just use a random number such as 65.98, just to show that doubles can be used. And for the final temperature of the gas in Kelvin, let's just say the user put 789. These are very random numbers, so it's going to give you in turn a random number, which would be 6.5 approximately. And as you can see, using doubles and being able to use the parsing, is able to use decimals instead of integers, which will only be integers. Let's run the program one more time and show what would happen if you didn't put a number or a valid answer. So for here, it's asking for A, B, or C. Those are the 3 valid answers. But for example, if I put something like 6, then it would say, oh, you didn't enter a valid answer. And it would tell you again which options are the main ones. And it would again ask you the question. And let's say I put it right, I put B, then let's you to go further. So for B, it was the ideal gas law, which would be Pervner, which is pressure times volume is equal to moles times the constant times temperature. And as you can see in the code, I provide several examples of this. And yeah, so this code took a lot of work, definitely some copy pasting, but mostly changing variables, doing calculations, and just trying to get the while and try statements to work, as they're very complicated and I was unfamiliar with Java prior to this program. So this program, although challenging, helped me a lot in learning Java actually. And yeah, so thank you for watching.